Good morning, guys. Welcome back to class. Today we are going to do lesson 6.5. And before the break, we were talking about radicals. And today we're gonna do that lesson where this is kind of the whole point of doing radicals, is to be able to solve radical equations. I think I've mentioned it to y'all before that all algebra is about is solving equations. So when you learn about radicals, it really is just to get to this point where you could solve something called a radical equation. So you need to know what one is, first of all. A radical equation is an equation that has a variable under the radical. So it's the placement of the variable that tells you whether it's a radical equation or not. It's got to be under a radical. So if you look at these two equations right here, the first one is a radical equation because look where the x is. The x is under a radical. The second one, although it has a radical in the equation, it's not a radical equation. This one is not, because look at where our variable is. It is not in a radical. So we're going to solve this one in just a minute, because solving radical equations is what this lesson's about. But I'll just mention what we would do here. Since this is just a number, it's kind of an ugly number, but it's just a number. To get x by itself, we could just subtract that number. Subtract radical 3. Got to get a new pencil, y'all. Look, my dog ate the pencil. Anyway, we would subtract radical 3, subtract radical 3. And this is what x is. X is this ugly number, 10 minus this decimal number, radical 3. So that's how to solve that, to get x by itself. We're going to be solving these today. All right, so there are only 2 steps for solving radical equations. This is kind of an easy process. First, you isolate the radical. You get the radical by itself. So anything that's with the radical, like in front of it or behind it, not under it, but anything in front of it, like on this one, the 3, and on this one, the 2, you have to move that stuff to get the radical by itself. So first, you isolate the radical, and then you raise both sides to the same power. Now, this same power, it has to be the power that undoes the radical. So the power that undoes the radical. Okay, so now let's do one. All right, example 1. First thing you have to do is isolate the radical. You have to get this by itself. Well, 3 has been added to the radical, so we're going to subtract 3, and you're left with this radical by itself. You don't have to write the plus. That just means it's a positive radical x. So square root of x equals 10 minus 3 is 7. Okay, well, we've done this for a while now. To get rid of a square root, what undoes a square root is squaring. So we're going to square this side. I'm going to use a pen. We're going to square that side. We're going to square that side. Well, the square root and the square, they undo each other. So you have x, and then 7 squared is 49. Now, let's say you're taking a test or something. If you want to know that you're right, if you were to plug, you can check it. You can plug 49 in right there. So 3 plus radical 49 equals 10. Well, square root of 49 is 7. 3 plus 7 equals 10, and that is true. 10 equals 10. So that's just a way to check it. Example 2. Step 1, isolate the radical. Now, if at any point you want to pause the video, do the problem yourself, and then press play again to see if you got it right, that's a good idea. It's a good way to learn. So subtract 2. The 2's are gone. Square root 3x minus 2. See, it was 2 added to the radical, so to get rid of it, we subtracted it. That gives you 4, and that leaves us with a square root. See, this is the radical isolated. All this is under the radical. To get rid of the square root, you square. And the square root and the square, they undo each other. You can even cross those off if you want. That leaves 3x minus 2. 4 squared is 16. And then this just became a regular 2-step equation that you guys could solve, no problem. So add 2. You get 3x equals 18 divided by 3. and you get x is 6. Again, you can plug a 6 in right there. And if you plug in a 6, that's 18 minus 2, which is 16. Square root of 16 gives you 4. And 4 added to 2 gives you 6. So you can plug it in and make sure that you are right. Okay, on the back. Or on page 2. See, in class, this would have been printed back to back, but my printer won't do that. At least I haven't figured that out yet. So here we go. We're going to solve this one. Now, this does not look like a radical, but it is, because remember when we did fraction powers, that's one of the last things we did before the break. Remember that this is the power, and this is the root, the radical. Powers are on the top, roots are on the bottom. We talked about roots being on the bottom because tree roots are on the bottom. Anyway, this doesn't look like a radical, but it is one because it's a fraction power. So this is a radical equation because the x plus 3, that's what's under the radical. The x is under the radical. So we have to get rid of this too. Now, the temptation here, because people see it right up next to the parentheses, is to distribute the 2. You cannot distribute a 2 into a radical. You can't do that. That's not the distributive property. So you can't do that here either because this is a radical. So we're going to get rid of that 2 by dividing. That's probably the hard part, is to recognize that you can't distribute that 2. That's probably what's going to be troublesome. So the 2 is gone. So we have x plus 3 raised to the 3/2 power equals 27. Okay, now to get rid of this radical, see, that's not just your average everyday square root. That's raised to the 3/2. Sorry, it was ugly. 3/2. So to get rid of that, we're going to use the reciprocal of 3/2. We're going to raise that whole thing to the 2/3 power. Now, I know that's weird, but we're trying to get rid of 3/2, and what gets rid of 3/2 is 2/3. Okay, here's why I'm doing that. So one of the things we did before the break too is we reviewed these power rules about radicals and powers, and I reminded you that whenever you have a power raised to a power, you multiply them. So when we have this power, 3/2, raised to another power, 2/3, we're multiplying them. And when you multiply those, you get 6/6, or in other words, these cancel, and you get 1. 6/6 is 1. If all those canceled, we'd be left with 1. So we've got x plus 3 to the 1. You just don't have to write to the little 1 power. But that's what's happening here. We're doing a power to a power. We're multiplying those. And when we multiply, you could either say that they cancel, or that when you multiply, you're getting 1, and raising to a 1 is just x plus 3. Now, if you don't know what this is, you grab a calculator and you go 27 raised to the 2/3 power, and you get 9. So 27 raised to the 2/3 power is 9. Here's why that is. This, remember, is a root. So it's a cubed root of 27, which is 3. But then we're squaring it. So that's why we get 9 here, because it's the cubed root of 27, which is 3, squared. All right, then we subtract 3, and you get x is 6. Okay, let's see what that would look like when you plug it in. So our original equation, remember, looked like this, but we found x to be 6. So I'm just plugging this into the original just to check it. And this is a 9, so 9 raised to the 3/2. You can do that in your calculator, 9 to the 3/2. It means square root of 9, which is 3, cubed, which is 27. So it's 2 times 27. You can do 9 to the 3/2 in your calculator if you want, and you get 27. And that really does equal 54. So that's just checking it if you would like to, especially on a test or something, if you have some time. Okay, next one. remember, at any time you can pause this and do one on your own. In class, I would say, okay, y'all do this one. So you could pause the video and do that at any time. You get x plus 3. So see, you can't distribute the 3 in there. You can't, because that's a radical. And so we're dividing by the 3 to get rid of it. It's still raised to the 3/4 power equals 27. 81 divided by 3 is 27. Okay, then here's what I want y'all to think about. What power would I have to raise it to? So think about that. To get rid of a 3/4, we're going to raise it to the 4/3. Raised to the 4/3. Okay, that's going to cancel. You can either say it cancels, or you can say 3/4 times 4/3 is a 1. So this is x plus 3 raised to the 1. 27 to the 4/3 power. 27 raised to the 4/3. Remember, I'm using the caret button to raise to a power. I'm using the fraction button to type in the 4/3. You get 81. Here's what that means. Cubed root of 27, that's 3. 3 raised to the 4th is 81. And then you subtract 3. And you get x is 78. Okay, up until this point, I want to mention something that we did recently called the even, odd rule. And I want to mention why it hasn't come up yet. Okay, the power that I put on each side, in this case, was a cubed root, so it's an odd root. Same thing here. The power that I put on was a 2/3, which is an odd root. And here, these weren't written as fractions, but that's a 1/2 power. Now, when I raised it to a power, it wasn't a root, it was a second power. And the same thing here. I wasn't raising to roots. So something comes up here that I need to remind you about from a little while ago. It's called the even, odd rule. So first, let's get rid of this 2. Again, you cannot distribute the 2. You have to divide by the 2. You get x minus 2 raised to the 2/3 equals 25. Okay, so think about what power I'm going to raise this to get rid of it. To get rid of 2/3, we need a 3/2. Okay, so here's the problem. The root that I put on is a square root. Remember, the bottom number is the root. So that's even. That root right there is even. And I'm taking it of this power. I'm taking this root of this power. Well, this power is even. Even power. And then when I do that math, remember everything cancels or multiplies, you get a 1, which is an odd power. X minus 2 raised to the 1. Okay, so what happened here is the even, odd rule. I took an even root of what was an even power, and I got an odd power result. And then you can punch this in a calculator if you want to. So here's what that means. 25 raised to the 3/2. You get this, you get 125. Okay, here's what that means. So a long time ago when this came up, when we took an even root of an even power and we got an odd power result, I don't know if you remember, but in the homework, we would put absolute value bars around that part. We would put absolute value bars around it, like that. Well, what's going to happen here is that's going to give us 2 different answers. See, way back in chapter 1, I mean, this was a long time ago. This was August, y'all. Or maybe September when we did this. Anyway, whenever you have bars in an equation, you have to separate it into 2 different problems. And so the first one, we would just drop the bars. And then the second one, you would drop the bars. You would flip that symbol, but it's just an equal sign. If it was a less than or a greater than, we'd have to flip it. And you make this negative. We called it drop, flip, and change. So you're going to get two different answers here. So you're going to add 2 and get 127. And you're going to add 2 and get negative 123. We actually get two answers to this. So the only time you have to do that, the only time is when the root that you put on, that fraction that you put on, if it has an even bottom number, that's when you're going to have to do this split and get two different answers. You only have to do that when the fraction that you put on the problem to solve it has an even number on the bottom, an even root. That's when that happens. Okay, so let me show you what happens just for checking it. Now again, you don't have to do this part. I would probably do it on a test just to make sure I'm doing things right if there's time on the test. So 127 minus 2 raised to the 2/3 equals 50. So look what happens. You get, inside here you get a 125. When you punch that in a calculator, you get 25. And that's 50 equals 50. So see, it worked. And then look what happens when we plug in negative 123. Negative 123 minus 2, that gives you a negative 125. And since this is a cubed root, cubed roots of negatives can be done. Square roots of negatives can't be done, but cube roots of negatives can. So if you were to raise this to the 2/3 power, you get, cube root of negative 25 is negative 5. Negative 5 times negative 5 gives you a 25 again. And that's 50 equals 50. So see, it worked. Both of those numbers worked, all because cube roots of negatives can be done. So that's what happens whenever the root that you put on, the fraction that you put on, if it has an even number on the bottom, we have to put bars around this, and we get two different answers because those two different answers work. Okay, that is all for today. And so you'll find on Google Classroom and on RenWeb that you have some homework over this. And that's going to end. There's more in Chapter 6, but that ends all the radical work. So the next thing is to review all that and to take a little test. So later on today, I'll post a video of some sample problems. If I didn't already, I'll double check. If I didn't, I'll put some sample problems from the review from last week. Okay, y'all have a great day. Bye.